In this lecture, we're going to look at Chapter 11, Compound Interest and Present Value. These are our performance objectives as also listed in your textbook. We are going to cover both sections of compound interest and present value. In Chapter 10, we looked at simple interest, and we looked at the formula I equals PRT, and that's where we calculated the interest once. So in business, another common way of calculating interest is compounding or finding the compound interest. And this is just when you apply interest a number of times during the term of the loan. Time value of money we talked about previously. It's the idea that the money that you have now is more desirable than some amount of money you could have in the future, with the idea being that the money you have now you can invest, earn interest, and make more money if you've got it now and you invest it now. So in this chapter, we will learn to calculate the compound amount, the future value of an investment at compound interest when the present value is known, and then we'll also learn to calculate the present value that must be deposited now at compound interest to yield a known future amount. So let's take a look at manually calculating compound interest. So we use the simple interest formula that we used before, I equals PRT. We calculate the interest earned per period. So each time interest is calculated, it is then added to the principal to determine a new principal. So compound interest equals the compound amount minus the principal. And we're going to take a look at an example. So what is the compound amount and the compound interest of $10,000 at 12% interest compounded semi-annually for 3 years? So when we do these calculations, you'll notice that number one, it's a lot of work. So I want you to be really mindful of staying organized and listing everything out. Now they've said here compounded semi-annually for 3 years. Semi-annually means twice a year for 3 years. So we're going to have to make 6 different interest period calculations. So you can see here, we start our original principal is $10,000. Our first interest period, right, our first 6 months is 10,000 times the interest rate, which is 0.12 times 0.5, because the time is half of a year. So it's $600. So our principal for period 2 is $10,600. We repeat this until we've done it 6 times, then our compound interest ends up being $4,185.20. So these are not difficult calculations. These just take time to calculate, and you need to make sure that you're doing neat work and make sure you're covering all your steps. So you don't have to work many compound interest problems manually, especially those with a lot of compounding periods. So there are 2 methods to solve compound interest problem. The first uses the compound interest formula, and the second uses compound interest tables, and we've got them in our textbook, page 345. So the compound interest formula contains an exponent and has to use, you've got to use your calculator and use the exponential function key. So we will go over that in just a moment. And then the compound interest table on page 345, that is a useful set of factors to represent the future values of a dollar at various interest rates for a number of compounding periods. And because these factors are based on a dollar, the future values of other principal amounts are found by multiplying the appropriate table factor by the number of dollars of principal. You can see here the compound amount, the future value, is the table factor times the principal. And the compounding periods is the years times the periods per year. Then the interest rate per period is the nominal rate divided by the periods per year. And here's an example of a compound interest table at various interest rates. And then this just goes over what each of these terms means. So annually is every year, semi-annually is every 6 months, which means there's 2 periods per year. Quarterly is 4 periods, monthly is 12, daily 365, and continuously is infinite. So the steps for using compound interest tables: you scan across the top row to find the interest rate per period. You look down that column to the row corresponding with the number of periods. The table factor at the intersection of the rate per period column and the number per period row is the future value of $1 at compound interest. So you multiply that table factor by the principal to determine the compound amount. So if we refer back to the problem that we just solved by hand, this is just another way to do it using the table. So you can compare this method to the manual method. These are the steps for creating new compound interest table factors. So it says calculate a new table factor and find the compound amount of $3,500 invested at 16% interest compounded quarterly for 7 years. So if you look at our table on page 345, you'll see that the periods, we don't have enough periods listed on this table to solve it. So this is what to do if you can't, your info is not on the table. It's how to break it down. So the interest rate per period is 16% divided by 4 is 4%. The number of compounding periods is 7 times 4 because it's quarterly, so 4 times a year is 28 periods. So that's where if you look at the table, we don't have 28 periods listed. So we are going to do 4% at 14 periods, 4% at 14 periods, and then we are going to get 2.9987156. Then we are going to, they've rounded it to the new table value times 3,500, and the compounded amount is $10,495.52. In describing investments and loans, the advertised interest rate is known as the annual or the nominal rate. It's also the rate that we use to calculate compound interest. So consider what would happen to an investment of $100 at 12% nominal interest. The greater the number of compounding periods per year, the higher the amount of interest earned. So although the nominal interest rate is 12% with monthly compounding, that $100 earns more than 12%. This is why many investment offers today advertise daily or continuous compounding. So if we take a look at this next exhibit, you can see compound interest earned on $100 at 12%. If it compounds annually, then you would earn 12%, semi-annually, or $12, $12.36, quarterly, $12.55, and then if it compounded monthly, you would earn $12.68. So you can see the difference that different periods make on the amount of interest earned. Before we do this, I want to go back. I missed the AYP. So the AYP or APY, the annual percentage yield, sometimes called the effective rate, reflects the real rate of return on an investment. So the APY is calculated by finding the total compound interest earned in 1 year and dividing by the principal. So make sure you're aware that this is actually the simple interest formula from chapter 10 solved for rate, where the t, the time, is 1. All right, now let's look at calculating the APY. What is the compound amount, compound interest, and annual percentage yield of $7,000 invested for 1 year at 6% interest compounded quarterly? So we're looking for a few different things. We're going to start with the interest rate per period. So it's compounded quarterly, 4 times a year. So 6% divided by 4 is 1.5%. If we compound the periods, 1 times 4 is 4. Then the compound amount is 1.06136 times 7,000. We got this number from our table. And then 7,429.52 is the compound amount. Subtract from the original amount of 7,000, you get 429.52 for the amount of compound interest. Then to find the APY, we take the compound interest divided by the principal, and we get 6.14%. So the more compounding periods per year, the higher the APY is. Let's take a look at calculating the compound amount, the future value, by using the compound interest formula. So A is the compound amount, P is the principal, I is the interest rate period, always expressed as a decimal, and N is the total compounding periods. So the years times the periods per year. So this shows the steps and the calculator sequence. We will use on our calculator the y raised to the x button for this calculation. So we are going to take a look. Here's more of the present value table. Calculating present value using the table. We're using table 11.2 from page 355 in your textbook, the present value table, present value of $1 at compound interest, to find out how much must be invested now, right, the present value, what we have to do now at 8% interest compounded quarterly to have $3 million 3 years from now. So they're telling us that the interest rate per period, 8%, we divide it by 4 because it's quarterly, we get 2%. Our compounding periods is 3 years times 4 periods a year is 12. And the present value, again we're referencing our table here, is 0.78849 times 3 million. So how much must be invested now? You have to invest $2,365,470 now to have $3 million 3 years from now. This talks about the steps to create new table factors, and we'll look at an example. So again, if you've got a problem and they've given you parameters that are outside of the table, how do you solve that? So calculate a new table factor to find the present value of $8,500 if the interest rate is 6% compounded quarterly for 10 years. So all we are going to do is follow our simple steps. We find the interest rate per period. 6% divided by 4 is 1.5%. We've got 10 years times 4 compounded quarterly, 4 times a year is 40. Then we break this down because we've got 40 periods. So we're going to figure out the value at 20 periods, and then that'll give us our 40 period calculation of 0.55126. And then when we figure out the present value of $8,500 would be $4,685.71. So how do you calculate the present value using the present value formula? We're using present value equals the compound amount divided by the quantity of 1 plus the interest rate per period raised to the total compounding periods. So this is our calculator sequence for your reference. And now let's do some review problems. And then I'm going to assign you some practice problems in the book. Before we do these review problems, I'd like to suggest that you go through your chapter and look at all the example problems, and I want you guys to also do the triad exercises. If you're not sure, do the triad exercises. All the answers are in your book. That's a really good way to practice the material that we've just covered. So, practice chapter review problem number 1. A firm is planning to build 5 homes, each costing $125,000 in 2.5 years. The bank pays 6% interest compounded semi-annually. Semi-annually means twice a year. How much should the firm invest now to have sufficient funds to build the homes in the future? So the first thing is we've got 5 homes at $125,000 each. So you need $625,000. It's a 6% interest rate over 2 periods because it's semi-annually. So that's 3%. The compound period it's 2.5 years, so 2.5 times 2 is 5, because there's 2 periods per year, 5. So the present value, we look at the table, we get 0.86261 times 625,000 means that we need to put in, or this firm, would need to invest $539,131.25 in order to have sufficient funds to build those homes in 2.5 years. All right, problem number 2. As a savings plan for college, a family deposited $10,000 in an account paying 8% compounded annually when their son was born. How much will the account be worth when their son is 18 years old? So this is a really good kind of practical example. So it is compounded annually, 1 time a year. There's 18 years times 1 time a year is 18 periods. We look on the table to get our value times 10,000. So that means when their child is 18 years old, that 10,000 will have grown into $39,960.20. So a firm deposited $500,000 in an account earning 12% compounded monthly to pay for the future construction of a warehouse. How much will be available for the project in 2.5 years? So it's compounded monthly. So we did 12% divided by 12 is 1%. The compounding periods is 2.5 times 12, which is 30. So we have to do the multiple calculations for the periods. We get the new table value of 1.34785 times 500,000. So in 2.5 years, they will have $673,925.65. So this is the last review problem. A bank is offering a 6-year certificate of deposit at 4% interest compounded quarterly, so 4 times a year. What is the annual percentage yield for an investment of $8,000? So here we do the interest rate, 4% divided by 4, because it's compounded quarterly, 1%. It's 1 year, because they want to know the annual percentage yield, times 4 is 4. The compound amount, we get our value from the table, 1.04060 times 8,000 is $8,324.80. And the compound interest is $324.80. So now we can calculate the APY. We do the total compound interest in 1 year divided by the principal, and it's 4.05%. So the annual percentage yield is 4.05%.